and we kind of focus on slightly different aspects of GI science. So my work is mostly around computational social science, lots of modeling, spatial statistics, with a substantive research area around transportation. And generally, most of my work involves some type of modeling applications. Karsten is also an assistant professor of geoscience here at Hunter College, also associate director, and he's in fact a computer scientist. And so he's interested in things like geospatial semantics, emergency information management, VGI, and he's probably one of the foremost experts on linked geospatial data. And so he's our sort of data guy, and working together, we try to combine our interests to answer some potentially useful societal problems. So today we're going to be talking about environmental monitoring and what we can do with that. So the EnviroCar project is a project that sort of originated out of some student projects and has been taken over at the University of Munster, and has been taken over by a research group called 52 Degrees North. And they are basically, as it says here, they're an open source geospatial software company, and they do quite a lot of R&D with geospatial software. They also have strong ties with groups including Esri and several other European universities. And so a lot of the work they do feeds back into these organizations and the organizations around that. They are also members, very strong members of the open source community, and they have a lot of engagement with OGC standards, Open Geospatial Consortium standards, and they provide lots of implementations of these communication and data standards for the geospatial world. And as I said, a strong member of the free and open source software for geospatial community. So we're very lucky to be partnered with this group, and they've provided a lot of the base ground materials and software and components that go into developing the EnviroCar project. So EnviroCar itself is pretty cool. It's this citizen science platform designed essentially for collecting vehicle-based sensor data. And most specifically, we tend to focus on CO2 outputs from moving vehicles. But in theory, the EnviroCar platform can be used to collect just about any type of data that we can gather from a car or truck or any type of vehicle's onboard computer. So it connects to the vehicle's computer via the OBD2 adapter. So if you are watching the presentation here, there's a little OBD2 adapter down on the bottom right of the screen. And that thing just plugs into the car's computer via the OBD2 interface, usually located somewhere underneath the steering wheel. And then it connects via Bluetooth to a smartphone, which collects in real time data from the car's engine, and it uses that information to estimate how much CO2 is being generated by the vehicle, what the engine temperature is, how many sort of metrics for fuel efficiency, and other useful metrics for looking at efficiency in vehicles. Okay, and there's the sort of contact information and info about the project is available at envirocar.org. We try to tweet whenever something cool happens, so you can follow us there. And then we also, it's an open source project, so all of the code and materials associated with the project are available online as well at github.com/EnviroCar. So basically what it does is, as you're driving along, it's collecting information from the vehicle's computer. We have some onboard models that estimate CO2 output, and then that basically tacks that along with the GPS information from your vehicle to create trajectories of data. All right, and so it stores things like fuel consumption, CO2 emissions, etc. And that trajectory can then be uploaded to the EnviroCar server, and it can be shared with other researchers. You can share with your friends if you like. You can also look at your CO2 emissions and your vehicle or driving efficiency through time. And when it goes up to the server, it's anonymized and then made available for other citizen scientists or urban planners or other people who might be interested in looking at the spatial distribution of various environmental indicators, such as CO2. So, this is a nice, simple diagram of basically how it works, where you connect to your car. When you're done a trip, you can upload the trajectory to the EnviroCar server, and then there are various ways that we can then interface with the data, including directly in a GIS via some very cool web APIs, which we're going to demonstrate a little bit later, as well as on the mobile phone app that comes with the project, as well as interacting with online web-based maps and things like that. So we'll try to demonstrate kind of all facets of that, short of trying to take you around in a car with us to show you how the whole project works. So hopefully you can see, it's probably a little bit jumpy for you right now, but this is actually our first track in New York City. And this is basically just a video recording of us playing back the track. And we actually generated this using standard GIS software, in this case a piece of software called CartoDB. I apologize if you can hear my phone ringing, but I can't actually reach it to stop it right now. So we'll just pretend that's not happening. But anyway, this is a video of the trajectory, and this is the type of data that we're generally working with, essentially a trajectory of data through time, and the color right now reflects the CO2 values. So here are CO2 levels along that full trajectory, and you can actually see areas where we have particularly high CO2. In one case is the sort of bright red uphill along the Queensboro Bridge, and then you can see that they quickly drop off as you're driving downhill on the other side of the bridge. And there are a few pinch points and things like that where there are traffic controllers like lights or stop signs, and all of these urban forms essentially impact the efficiency of your driving, which in turn impacts the amount of CO2 that we estimate the car to be producing. So one of the things that we're particularly excited about this is we're hoping that it's something that citizen science can engage with. So as users interact, they can actually learn about their different driving behavior. It actually stores or they can store their data through time, so they can look to see if they're becoming more and less efficient. And eventually the goal is actually to be able to suggest to users ways that they can actually improve their driving efficiency. So the idea here is, in theory, there's the potential there to help people reduce their fuel consumption. But probably from our perspective as researchers, the really exciting thing is that this has the potential to generate a fairly large pool of not only emissions data, but also traffic data for various urban areas. We have relatively good coverage for Munster. We have now just a few tracks in New York City, and we're trying to promote use in other cities as well. So we have partners in other cities, including London, here in New York, and we'll be expanding the network over the next year or several years to try and get a fairly broad coverage of different urban areas. And ultimately, what we're interested in is looking at the detection of various different environmental or traffic problems in these urban areas. So that's kind of what we are focusing on at the moment, is the use of the EnviroCar project for environmental monitoring. And in particular, we've been looking quite a bit at hotspots and various urban form features and how they influence CO2 outputs. So for other researchers, we're hoping that this will be an exciting opportunity as well. As we mentioned, the data is all publicly available, and it's actually made publicly available as open linked data. So as we move on and collect more data, it should be relatively straightforward to actually combine this with alternative data sets, combine it with stationary sensors, annotate the data, and validate it that way. And so there's quite a lot of applications that we can employ. And as I said, it's all open data for other researchers to use. So we're starting to look at applications for looking at idling and looking at perhaps suggesting areas where we might enforce idle-free zones, looking at congestions, speed bumps, and their impact on driving behavior. And essentially, the final goal is to get a nice, clean data set that we can use for decision making and planning down the line. So here is a quick view of some of the CO2 hotspot analysis that's being done. And this actually is available online right now at that link. And we can make these slides available to people afterwards if they're interested, if you can't jot down that link fast enough. And you can actually go online and you can interact with the data, and it's all available through Esri ArcGIS Online map viewer application. And of course, because the data is accessible via an open API, if you want to use this data in your own map interface or with your own base maps or whatever, that's completely possible. And we'll actually show an application of using an alternative GIS framework in a little bit. Okay, so I'm actually going to pass the mic over to Karsten Kessler here, and he's going to talk a little bit more about the data and some of the really cool things that you can do with it. So here he is.
Hi, everybody. So I just wanted to quickly go back to this map because there are a few interesting things to see here. So there are obviously 3 areas with high emissions on the bottom left here of the screen, and on the top center of the screen, and then here on the right. Oh yeah, right, you should be able to see my mouse pointer. So these areas here. The blue areas are cold spots, so that's where the emissions are particularly low. The area here at the bottom right is actually where the 52 North offices are. So I guess they've been just driving around relatively slowly in the parking lot to test new features. And the area here on the upper right, that's blue, that's actually where I used to live. I'm not 100% sure why it's a cold spot. I assume that it's because the streets there are really narrow, so you kind of have to go slow. The 2 hotspots on the left side of the screen, there are known to be congested areas in the city, so there's always a lot of traffic and you have to go slow, a lot of stopping and starting again and so on. The area here on the right of the screen is a little bit unexpected. It's actually residential, and then on the other side of the street it's just fields and meadows. But when you look at the data a little bit closer, you can actually see that there are a couple of speed bumps here along this red patch, and so there's not a lot of traffic. So what people do is they slow down, go over the speed bump, speed up again up to the next speed bump, slow down again, and so on. So maybe a little bit safer because it forces drivers to slow down, but from an environmental perspective, it's very inefficient. So just wanted to highlight some of the things that you can actually see from these tracks if you combine them. It's quite interesting. So let's take a look at how we can get at the data. Carsten mentioned already that it's all open source, and the data actually sits on the EnviroCar server in a MongoDB, so in a schema-less database. And from the outside, so if you're not running the server yourself, there are a number of ways to access the data. For one, if you have an account and collect your own data, you can just log in at envirocar.org and download your own tracks. Or you can use these various APIs and scripts to access the anonymized tracks of other users, and that's possible for everyone. So there's no account required or anything like that. I will just quickly go to this portal here. So this is a portal on ArcGIS Online that shows the different types of maps that have been created yet so far with EnviroCar data. There's even an R framework to analyze the data. Maybe we can just take a quick look at the global overview just to give you an idea of where we have data already. It takes a little bit to load. ArcGIS Online is not the fastest platform. It should be coming. there we go. So see that there's quite a lot going on here in and around Germany, a little bit in Spain, and then we have a couple of tracks here on the west coast, and then there's this tiny green dot that maybe you can't even see on the stream, but there's this tiny dot in New York City. Oh, and actually, I hadn't noticed that before. Carsten just points at Australia, so down here we also have quite some activity. And in Sri Lanka. Oh, okay. Well, I happen to know that someone at 52 North who's involved in the project, his girlfriend is originally from Sri Lanka, so I assume they went for vacation and recorded some tracks. All right, let's go back to the presentation. So how do you get at the raw data? Carsten mentioned that this is open data. It's actually under the open database license. It's the same license that OpenStreetMap uses, for example. And it's accessible through a REST API. And I've mentioned everything else on here. So just a quick look at the data model so that you get the idea. So the main idea for, or the main element for a track as such is just called track. My mouse pointer. It's just called a track here in the center, and then every track basically contains information about the different sensors that it provides. So that will be speed, fuel used, CO2 emitted, a number of revolutions, and so on. And then for every sensor, you get measurements at every single GPS point, and every measurement is for a specific phenomenon. Yeah. So this is when you're accessing a specific track, and then every track belongs to a user. So if you go or if you access the API with authentication, then you can basically directly access your own tracks through your user ID or your friends' tracks if you're in the same group. So you can also create groups, basically a tiny social network functionality, so that you can set up competitions for most efficient driving, for example. This is the API endpoint, so it's just envirocar.org/API/stable. There's also a development API where they basically test new features before they add them to the stable endpoint. And all these elements that I've just mentioned in this overview are basically accessible through the API. And it's quite well documented. I won't show it right now, but at this page here on GitHub, you find quite a detailed documentation of the API. So I'll just give you a quick walkthrough of of how to export the tracks. So like I said before, you can do that at envirocar.org if you're a member, but let's assume we're just someone from the outside who wants to use the data. One way to do this is to ask for tracks within a bounding box. So here you see envirocar.org/API/stable/tracks, and then as an argument, you just pass the bounding box. And you may recognize that this is roughly New York City. So if I click on that, maybe a little bit small to read, but this is what we get back. So we get back the IDs of the 2 tracks that we have in the city so far. So you can see we need more people who collect data for us here in New York City. And then you can basically parse this response. It's just JSON, a standard JSON format, and ask for these individual tracks. So this is one example here. So instead of asking for a bounding box, you just check in the ID of the track that you're looking for, and that's the same thing. It's just a JSON response, and I'm going to save that right now. Oh, yeah, page source, and then just save it as .json on the desktop. All right, so we've saved the file. Somehow the mouse pointer is gone. Oh, there it is. All right. So with this JSON file, it's standard JSON, so it's not GeoJSON, but we can still take it and, for example, put it into, where's the CAR2DB window? All right, so let's take our track that we've just downloaded, and just to show you how easy it is to use the data, we'll just throw it in here, uploading, crunching some numbers, and here we go. So CAR2DB just takes the data, and it's one click on map view, and there we go. We have our track mapped. See, that's actually a different one from the one that we've had before. This is, I think, around Columbia. So the only problem with the JSON data is that if we go back to the data view, and I don't know if you can see that on the phenomenons here, so the actual measurements that we're interested in are just stored as one single string. So basically, CAR2DB doesn't recognize them as individual fields, which is what we want. You would get the same with QGIS or ArcGIS or whatever you use. So to handle that, the API actually supports two alternative data formats. So you can ask for the same data in shapefile format or in CSV format. So I will just download that same track in shapefile format now, and notice it's the same URL as before. The only thing that's different is that you add .shp for shapefile or .csv for a CSV file at the end, and you will get back the data in that format. So now we've got a shapefile. Okay, downloads. Where is it? No. Can't you just wait a second? Okay, there it is. So the only thing that doesn't quite work with the shapefile format is, as you all know, shapefiles are not single files, so you actually have to rename this to zip, and then this, if you unzip it, that folder will contain everything you need. So here we go. There's a shapefile with the DBF and the projection and all the files we all love. So instead of throwing this into CAR2DB again, I will just throw it into QGIS this time. See if that works. It should. Right. Zoom to the layer. And here we go. It's probably a little bit hard to see, but now we have actually all the different all the different columns as separate columns in the properties table, and we can use them to make graduated symbols, for example, based on oh, where's the column? That's interesting. Okay. Okay, so you can see the fields are all here: intake, temperature, throttle, CO2, and so on and so forth. I don't know why QGIS is acting up now and doesn't let me Okay, well, maybe let's try that with, well, the zip file is gone, so I can't upload it to CartoDB anymore. Okay, let's skip this part. It's going to take too long. But you see, you can get the data in alternative formats and that are a little bit more compatible with standard GIS environments. And JSON is just handy if you want to talk to the service directly from a web app, for example, and process the data through JavaScript and display them on a web map, for example. So that's in QGIS, I've shown that. CartoDB, I've shown that. I briefly mentioned this before. There's even an R package and an R tutorial to access EnviroCar data. So if you want to do statistical analyses that go beyond what you can do in a desktop GIS, then this is the place to go. These examples here show, for example, interpolated fuel consumption along a track or a comparison of different trajectories on the same street. I'll hand over back to Carsten now, and thank you very much.
All right, thank you, Carsten. So yeah, as you can see, it's actually pretty straightforward to actually interact and use this data, and that's one of the main goals of the project. And part of the whole idea of initially making this a citizen science project. So the idea here is it's crowdsourced data, it's totally anonymized, it's available and published in multiple formats so that lots of people can use it. And the eventual goal is obviously for continuous coverage. And in theory, if we reach a goal where many people are using it, then we get continuous and very frequently updated coverage as well. So what we'd really love to see at some point is some commercial entities picking up this type of application in order for their own uses to monitor usage, but then to provide data sets for planners and things like that as well. So in New York City, the obvious example would be taxis, getting this type of technology inside of taxis to collect continuous environmental data, which is fairly continuous coverage of the city. So this is just a quick map of taxi pickups and drop-offs in the New York City area. But you can imagine other commercial entities also collecting this type of data. So delivery companies, anyone who potentially has a fleet of vehicles that are driving on a fairly regular basis. So there's lots of city groups that we would love to meet with and talk to about this, but private entities as well could benefit from this. And part of the EnviroCar project that we worked on this summer was actually developing a way so that these companies could actually have their own EnviroCar app, which collects data specifically for their company. They would have their own company group, and you can limit access to the data and things like that, so that if you don't want all the data to be publicly available, you can collect it and use it for your own purposes. And then we would hope at some point release some form of aggregate data to planners and researchers. In particular, that project that I mentioned over the summer was supported by Google's Summer of Code project, and we had an excellent student, Raul from India, who was working on that. And so that's a great project for those who aren't aware, where Google essentially funds a student to work on an open source software project. So we were very happy to do that, and should definitely mention that part of that funding came from Google. So here is a map of the coverage that we have for the moment, looking essentially at CO2 at a fairly global scale. So don't try and do any science from this image, but it gives you a nice overview of the idea. And so this is just the first few tracks in a few areas, but you can imagine this type of data expanding and getting fairly wide coverage. So we're very excited about that. So just to give you an idea of what we've been doing with this data so far, we've done a few initial analyses. One of the things that we're doing is actually looking at using the data that we have for Munster, which is quite comprehensive, and using that to annotate traffic flows in the New York City area. So currently that's based on fairly simple models of aggregate traffic volumes, where we calibrate a model based on traffic volumes in CO2 for Munster and apply that to traffic volumes in the New York City area. And it's very difficult, obviously, to validate these without access to a comprehensive ground network of sensors, but we seem to be getting some fairly promising results. And basically this right now is really just a demonstrator project for the EnviroCar platform, and as a way to sort of demonstrate the potential of the platform should we actually get some reasonable coverage in various other areas. We've also used some of this data to explore the impacts of various urban form features on emissions levels. So Karsten mentioned looking at the traffic calming areas as an indicator of potential CO2 spikes. So this has been kind of implemented in an exploratory GIS framework that many people employ every day for their own work. And basically what we were looking at is identifying urban form features that seem to be associated with CO2 hotspots. And probably one of the most interesting ones was the traffic calming areas. Particularly interesting because we often place these in areas around parks or schools where we have children playing in order to reduce traffic speeds. And by making it slightly safer in terms of traffic, we are at the same time making it less safe in terms of CO2 and other forms of emissions. So here is just some visuals of some of the types of outputs that we are looking at. In particular, the traffic calming example is quite interesting. The map on the left here is the model based on traffic volumes, and it's just essentially a proxy or a simple model for predicting CO2 based on the Munster data. So essentially what we've learned so far from this data is a lot of urban form features do have some form of impact on fuel consumption. As I've mentioned, the traffic calming ones are of particular interest, although things like roundabouts and traffic smoothing features also seem to produce CO2 cold spots, which is what they're often designed for. But we have also found that driving style and ultimately the individual driver plays a key role as well. And one of the nice things about the EnviroCar data is while all the data is anonymized, we can control for individual drivers by using the anonymized user IDs, which have no linkage back to any particular individual, but we can look at our own tracks to look at changes through time, and we can look at aggregate views of different driving or vehicle types, different engine types, and things like this to actually get a more nuanced look at actual CO2 creation or CO2 production. So there's a mention of that traffic calming in urban environments findings. Some of the other features that we are particularly excited about and that we're working on right now actually include extending the framework that we have so far to actually allow us to both augment and compare the EnviroCar trajectories. And so Karsten and I are developing a framework for essentially augmenting or annotating the trajectories with fixed sensor data or any other type of environmental data that we might want to apply. So this is essentially addressing questions or statements such as show me all sensor networks, or sorry, sensor measurements in the area surrounding a particular EnviroCar emission peak, for instance. And that would help us identify possible causes or for the peak or possible other sources for validating those peaks. And then, of course, techniques and tools for comparing the CO2 augmented trajectories. So we can start to do things like ask to show all EnviroCar fixes that deviate from local sensor network observations or things like that, in addition to comparing trajectories between one another. And then probably the thing I am most interested or excited about in terms of sharing this with other researchers is that we're putting a lot of effort into developing software and GIS tools to facilitate exploration of the data by other researchers as well. So there are various tools for importing EnviroCar data into various GIS, including the development of some plugins. We're developing a plugin for QGIS to import the data directly into there, as well as data import tools for Python, R, JavaScript, ArcGIS, and any of the other platforms that we are working with. And we're very interested to hear from others who may be interested in using this data and use a different platform or a different workflow, and how we might be able to help them integrate EnviroCar data into that workflow as well. So the idea here is really that it's about facilitating the usage and exploration of this data in other environments. And again, I should mention that the excellent funding and opportunity we had this summer to have a student working on the actual Android applications that we actually use to collect and annotate the data. So that was very helpful, and that project will continue to be ongoing. So what we're hoping is that researchers will start to use this data to answer questions that they may be asking. So we've been looking at urban form and its influence on fuel consumption, and potentially issues of urban sustainability. But one of the things that some of our colleagues in Munster are talking about is how traffic planning can be optimized to actually reduce emissions. And so their city planning department is actually interacting with 52 North around this EnviroCar project to see if they can actually use this data to help planners on the ground actually making choices and making planning decisions based on traffic movements. And then ultimately also to test to see if particular sustainability initiatives that a city is implementing are working, right? Because if we can get continuous real-time or near real-time coverage, we can actually see if an initiative is actually being effective in fairly near time, which is a powerful thing to be able to do. Right now, we're focused mostly on CO2 and issues of speed. But the framework that we've developed really is about collecting data in moving vehicles in near real time and annotating trajectories. So we can look at things like congestion. We can use it to look at estimated exposure for pedestrians, and potentially using additional sensors on the phone and on the onboard computer of the car to look at things like potholes and obstructions. Does the car have to brake suddenly? When it runs over a pothole, the sensors in the phone actually can register a bump. We can look at wait times and things like that, and we can actually do that already to look at issues of congestion. So there's quite a lot of things that we can do with the project, and we're hoping that with as we continue to get some funding for students and other faculty to work on this, we'll continue to collect these types of data and provide essentially a data set that can be used for as many facets of planning as we can imagine. So we're pretty much done here talking about the project. If anyone liked what they saw here, if you have an Android phone, right now we only support Android phones, although I know there will be a question about iPhones, so the answer to that question is yes, we are thinking about it, and we're hoping to get that going next summer. But if you have an Android phone and you use a car on a regular basis, or even just infrequently, let us know. We have OBD2 adapters available. They're also available on Amazon for about $10 a piece, so they're pretty inexpensive if you want to get involved as a citizen scientist. But we also have some OBD adapters here as well, so if you're interested in getting involved, please get in touch and we will be happy to send you one. And if you get tired of using it, you can send it back to us, or you can pass it on to a friend and get them to do it as well. The app that you need for the Android phone is available in the Google Play Store, so you can just download it right there and it's ready to go. And it's very easy to set up. though we are happy also for emails if you have any questions about that. So please do get involved if you're interested. And then some self-promotion, I suppose, at the end. I hope that's all right. Karsten and I are running a masterclass this January on open source GIS software and technologies. That'll be running January 19th to 23rd. It's so it's an all-day event from 9 to 5. We're going to be covering everything from QGIS to PostGIS, database backend, right up to web mapping and some web-based front-end stuff. So it's pretty much looking at the whole open source GIS software stack and how you can take your existing data sources and workflows and basically fit it into this open source framework. So the link there for more info is there. Check it out if you are interested. Or if you just do a web search for Hunter Continuing Ed GIS, you should find us pretty quickly there as well. Okay, so I think that's pretty much it from us. Thank you very much for listening. And I think, look at that, exactly on time. I'm very impressed with myself. And so now I think we have some time for questions. So I'm going to minimize this screen so that we can actually see the questions and hopefully answer them as we go.
Okay, are you able to see the chat, Carson?
I think so. Well, I think maybe well, I guess we'll keep sharing our screen in case
there's a question
to demonstrate something.
Okay, I can read the questions if you want.
Okay.
I have 3 questions.
Okay.
First one is from Vanessa. It says, are you taking into account 3D models of city surface? Because more CO2 could be a result of an urban canyon that concentrates it. And how are you dealing with that?
The first one, are we taking into account 3D models of the city surface? We are not doing that yet. That is a very good idea. We actually do have access to excellent 3D models for the city in New York here, so we could definitely incorporate that into some of our analyses. That's an excellent comment, and thank you very much. We know, but now we will.
Okay, I have another question from Christopher. Christopher asks, are the points of measurement taking into account how fast the car is going? For example, an amount of CO2 reported at one point can vary if the measurement is for 20 feet compared to 20 meters.
Good. Good question. Actually, I might, is that written down somewhere so I can read it in my head again? I don't see it on the...
I'm not sure if you're able to see the...
Oh, yeah. Sorry. Here it is right here.
Okay.
Okay. Are the points of measurements taking into account how fast the car is going from CO2 reported 1 point can vary if the measurement is for 20 feet or 20 meters? No. It's not taking that into account. It's just so yeah, it's just a measurement for one moment in time. So it's whatever the engine output is at that exact moment in time, and the CO2 values are estimated from exactly what was measured at that moment. So it's a regular time interval. So as you said, if you want to ascribe a measurement to a particular length of the trajectory, then that's maybe not the best thing to do. Instead, it's really just for that single point in time. Does that make sense? Can you go back to the...
Did you want me to read another question, or?
Yeah, I'll pass it to Carson, and I'll let him answer the next question.
Okay.
Which one is next?
Elizabeth, can you see that?
Oh yeah, the ID associated to individual collectors, though anonymous. So the ID is actually, if you access the data the way that we did here when I showed it, you don't even get to see the ID. So the ID is only visible if you are authorized and if you are either it's your user ID or you're friends with that user. And about the setup, yes, when you first install the app and open it for the first time, it will ask you for the model of your car, because that's basically the requirement to be able to calculate the CO2 emissions, because the CO2 emissions, I don't think we've mentioned that, the CO2 emissions are not measured by the CARS computer. So that's not something you get out of the OBD interface. Instead, what you do get is the gas intake, and then if you know the model of the car, specifically the engine displacement, then you can calculate the CO2 emission from that.
So it's a calculated emission?
Yes, it's a calculated emission. How do you assess for quality and accuracy if it is citizen-centered? Well, that's always a very good question. I mean, most of it, I don't see a big issue with this in this case, because many of the citizen science projects depend on the citizens making observations. And like this classical birdwatch example, you never know whether the person who counted the birds did a good job or not. But in this case, the citizen is really only carrying the phone and driving the car that's collecting the data. So this problem that the citizen may either knowingly or just because he or she is inexperienced in doing that, reporting low quality data, that's really not an issue here, I think.
Great. There's one more question from Alan.
Alan, yeah, could it be used to identify idling trucks and buses? How about trucks that are burning oil? Well, if they had the app installed, it could of course be used to identify idling. Yeah, trucks burning oil, that is a problem. In fact, we don't support diesel cars yet. That's something that's still a little bit of an issue. Also something we're working on. But if you have trucks burning oil, I'm wondering whether they have an OBD interface at all. So I don't know about that.
Okay, I think that's the last of the questions from the attendees. I don't have any questions per se. It was a very thorough presentation. I had a bunch of questions at the beginning, but you answered almost all of them. So that's great. That's good. I did have to have one comment. I mean, as you probably know, the last 10 to 12 years in New York City, there's been a lot of new urban forms placed in places like Times Square and Herald Square, and places that are deliberately intended to slow things down and create traffic constriction. And I think it'll be very, very interesting to see if what kind of results you get for those specific areas, and see how that parlays into future implementation of those types of forms.
That would be very interesting, but for that we would have had or we would have needed EnviroCar before they started doing that to make the comparison. So
correct. That's true.
A little bit too late for that.
Yeah. Well, I mean, it can be done. I mean, I'm sure they're still considering it in other areas as well.
I'm sure they do.
And also, I was just, other than taxis in New York City, are there any other options that you guys have considered in terms of what type of fleets you could use to gather data?
Well, we're basically open to anything that has a motor and is driving as much as possible. So it could be parcel services, delivery services, limousine services, fleets of different city agencies that are on the streets a lot. I think there are a lot of options, and this is why we're shopping this around so much right now, because we want to get in touch with people who think this is a good idea and might put it in some of their cars.
Okay, great. Okay, are there any other questions from the audience? I don't think so. So I think we're all done.
All right.
Yes. Great presentation, great application. I can see a lot of uses from this. Tag along to Vanessa's question there with the 3D model. It would be interesting to see what the wind pattern for particularly like large cities like New York City or larger cities, where particularly hotspots we'd see on a map just from the emission point of view, but then with the 3D model and of the city along with the weather change pattern, you might induce and see another different hotspot in different locations.
Absolutely. That's something we've thought about, but we haven't looked into that yet.
Okay, there is one other question. I think before we close, Garvis is going to talk a little bit about where the recording of this presentation is, but we also have a question from Elizabeth saying, how can we get access to these slides?
Yes,
go ahead, Garvis.
I was going to say, if the presenters wish, they can upload onto the site, and then it can be accessed through the New York State GIS Association that way. And also with the video of the webinar as well, I think there is also a link from our association to that, because it will be placed on the YouTube channel as well.
Oh, okay, good. Yeah, we will definitely upload it, so and you have access to the slides.
And what is the name of the YouTube channel, Garvis?
That I have to find out. Maybe I can send to all the attendees, because I do not know it right off the top of my head right now.
Okay, I'm sure if they searched for New York State GIS Association, they probably would be able to find it.
Yes, if you just go to New York State Association.net, they can go right access with that and then see the past webinars. There will be a link to that one as well, I believe.
Oh, there it is. Susan just typed it in. It's NewYorkStateGIS.net. That's the website. Okay, this has been a wonderful presentation. Thank you so much for presenting this, Carson and Karsten. I'm particularly proud to have you two doing the first presentation, since I am alum of Hunter, Geography MS program. And so thank you so much for having us. Is there anything else you need to say, Garvis?
That is it. This is a great presentation, and thank you very much for your time, everybody, and definitely for the presenters.
Great. And like I said, anybody who is interested in joining the Transportation Professional Affiliation Group, please contact me, and we will hopefully be doing some more webinars in the very near future. Thank you so much, everybody.
Thanks for organizing this.
Thanks, Carson.
Thank you. Have a good day, everybody.
Bye-bye.
Bye-bye.